All right. So we just went over the Chapter 3 calendar for December. Please make sure you're ready for anything that's coming up, the quiz tomorrow and the test a week from Friday. So we're going to jump right into section 3.4. I'm going to give you guys a second to kind of write this down. Our goal is to evaluate and expand logarithmic functions, and once we know how to expand them, then we can go the other direction and we can condense them. And you'll see benefits to all of the rules that we're learning, not only this year, but again in calculus. You use these rules, so we want you to be well prepared for that. All right, so I'm just finalizing the first attendance check. Okay. So let's look at this. And what does the power rule do? The power rule is just a special rule that we can use to help us evaluate logarithmic functions when we have a power. And that's the piece I want you to connect with, is this idea of the word power. Well, right now I've got r to the power of c, and I'm going to do the log of that with the base b. Now, all this is generalized into variables, but we're going to look at it mostly in numbers. But all I want you to think of is this log, oops, let's do a different color, can come down out in front as a multiplier. So the c is going to come down, and then we'll be able to just multiply the log of base b times r. So anytime you see an exponent of a log or natural log, the power can come down right out in front. And that might not make a ton of sense until we kind of get into some problems. So we're going to look at this first example here. Notice I've got the log of x to the fourth. The base isn't written, and we got to remember we can always put a 10 there if we'd like. All right, so what's going to actually happen is this 4 is the power. That 4 is going to come down in front. And then we're just going to leave everything else the way it is. And officially, you don't have to write the 10 there just because it's a base of 10, but I always like to write it just so we don't forget. All right, but as we've learned, it really doesn't matter what the base is, if it's 10 or if it's something else. Why don't you go ahead and do this one here quick? All right, so we've got the power of 3. It's just going to come out in front. and it's the log of x base 4. Now, so this is just one small rule. We're most likely going to apply it with other rules, and that so it's very rarely is it just one rule that we tested. A lot of times it's combined together. Oh no, great question. I made a mistake. Sorry, I was trying to balance attendance. This 4 right here should not be here. I apologize. I accidentally wrote that. I was getting distracted by people coming in late and logging attendance. So good catch. Thank you. There should not be a 4th power here. So like we had, the 3 comes down and stays out in front, and then it's just the log of x to the 4th. Or excuse me, x to the base 4. All right, let's look at another rule. And we've got 3 rules today. This is the product rule, and hopefully when we think of the word product, you think of multiplying. So product is, we have r times s. Right? Now, when that happens, you can actually rewrite the log as 2 separate logs. So I'm going to rewrite this. They're going to have the same base. So the base doesn't change, but it's the log of r with base b, and then the product actually turns into the sum of the 2 logs. So let's look at these 2 examples, and we're basically, now you'll notice some of these are combined together. There's multiple rules, and that's the goal, is we want to be able to apply, if we need to, all of the rules at once. So watch how I do this, and it's not really applying them all at once, it's applying them in pieces. So when I look at the first example, we got the log of 7x to the 5th. Well, I've got a product, right? I've got 2 things being multiplied together. So I'm going to first use the new rule, the product rule. We're going to split up this log 7 and x to the 5th. So it's going to turn into log 7, and then the product turns into the addition of log x to the 5th. So that's just applying the product rule. And some students like to write, okay, what step did I do? I applied the product rule. But then notice we also have this exponent, right? So that actually can come down in front and now my most expanded form is, what would log 7x to the 5th actually be be written in terms of fully expanded? It's the log of 7 plus 5 times the log of x. Now you could, if you wanted to, put a 10 in each one of these spots, right? Because there's officially a base 10. If there isn't a base given, it's always a 10. But in that case, we don't write it. So if you wanted to identify what happened from this step to this step, we did the power rule. Okay? But again, you don't have to identify the steps, it's just kind of following through. So if we look at this example, you can hopefully see that we do have a product. Right? But each product has its own exponent. And I'm going to show you in the notes right now the 2 steps because it's important to understand that. But if I was doing this on the homework, I would go right from this piece to the answer. And once you get the hang of it, you can totally do that. So my product is x to the 5th times x to the 4th. We're going to split that up as a sum of the log of x to the 5th plus the log of y to the 4th. So there's my product rule. But then I'm going to apply the power rule and just put those exponents out in front. So we didn't officially call it this yet, but these final answers are written in expanded form. All right. So we had the power rule, the product rule, and now we've got, we got a couple more examples. I want you to try these two. Notice it says use the power rule to write the expression as a single logarithm. So we're doing the reverse of that. This is an expanded form right here. And then we want to go from expanded to what we call condensed form. So can you undo the rules that we just talked about to figure out what is the most condensed form of this piece and do the same thing for this one? So go ahead and try that quick. Okay, let's take a look at this. And again, you could do all of this in one single step. I'm just going to basically apply the first rule. If I have a constant, that constant came from the power. All right, so basically the 4 was from a to the 4th. And then I've got addition. When I see addition, I think the product. So it's the product of the two pieces. Notice, by the way, this has to be true. I should have pointed this out at the start. The base has to be the same for us to apply these rules. If we have different bases, then we cannot apply the rules that we just learned. So now, because the bases are both 10, then we've got the log of the product of a to the 4th times k. And officially, this is the answer that would be accepted. Or you could put the 10 here. Now, you're going to be doing work in Delta Math, and I'll just let you in on a secret. Because it's really difficult for us to kind of put a 10 in the lower subscript here, almost all of your answers are going to be just regular log. So the base 10 is assumed, which means we wouldn't write it. So then you would, if you're typing this into Delta Math, you would only type the log a to the 4th times k. Okay. So here on the second example, we've got two powers. So both of those, or I should say two constants, both of those need to move up as a constant. And that's technically the first step. So we got a to the g plus the log of b squared. So we basically undid the power rule. Now we have addition of two logs that have the same base. which is undoing the product rule, which says I'm going to take a to the power of g and multiply it by b squared. Okay, and I believe if this was, let's say this was a delta math problem, here's what they would do. They would have it like this, and that would be in their box. And then your job is just to write the what is inside, or technically inside, what are we taking the log of? And sometimes if the base is different, like if it's a b, they'll put the b down here so you don't have to put it, and then you just fill in this spot. So that's the way they're going to kind of get around the fact that it's hard for us to program a subscript in the denominator, or I shouldn't say denominator, in the lower part for the base. Okay, last official rule, and then we've got one more item called the change of base that comes up. So we did powers, product, which is multiplying, so now we have quotient, and quotient is referring to division. So what happens if I have a fraction inside, I'm taking the log of a fraction with a certain base? Well, the base is going to stay the same, but we're going to be able to separate the r divided by s, and we're going to be able to rewrite that as the log of base b of the numerator minus the log with the same base of the denominator. So basically, when I see division, I think subtraction. When I see multiply, I think addition. Okay, and then we're going to do these two examples together just because I want to make sure you guys kind of have that same idea. And we have to be very careful with these, with how we write them. So notice the first one. So this is in condensed form. We want to break it down and we want to use the rule to expand it. So here's what I'm going to do. I'm going to first deal with the quotient. Right? We're going to use the rule we just learned to split it up. So I've got the log of, technically there's a 10 here, but again, we don't write the 10. But I've got the numerator minus the log of the denominator. And they both have the same base. That's the reason why this works. But now we're not done because we have to look at this answer, or the first part, and this is going back to basically keep expanding. So you're going to keep applying these rules, and like we have here, sometimes you apply all three rules in the same problem. So now, notice how we have a product here. So I have to split up this first part as the product. So it's going to be the log of z plus the log of y to the third. And you might be thinking, ooh, I know what to do with that 3. And then the part of the quotient, the log of x, just stays at the end. Okay. So now I've got the log of z plus the log of y, but that 3 is in the exponent, and that's going to come down in front as a multiplier. Now notice, the 3 didn't come down in front of the z. That's important to note. This 3 doesn't come down because I have a product of z times y to the third. That third power only belongs to the y, so it's going to become the multiplier out in front just for the log of y. And then this would be the expanded form of our original statement. Okay. If you would like, some people like to kind of write the steps. What did we do from here to here? We used the quotient rule. Okay. And then from basically here to here in blue, we used the product rule. And then the last step, this 3, this was the power rule. So hopefully you can see all 3 rules being applied at a different time, but all within the same problem. So I want you to go ahead and try this second one here. See if you can deal with that. My hint for you is do the quotient first. Deal with the fraction first and then break it down. Okay, so let's deal with the quotient part first. Quotient is going to tell us to subtract the numerator and the denominator with the same log. So that's the first step. And then you can kind of do 2 steps in one here. And you could technically, if you really understand what's going on, you could just write your answer all out in one step. I don't recommend it because it's always good to just review the separate rules. But if I deal with this z first, z to the 4th power, well, that 4 is an exponent. It's going to come out in front. And then here's the part you have to be super careful with. Right here. Now I should have done this here, but it doesn't affect the problem. Officially, we're subtracting whatever's in the denominator. Right? Now notice we've got more than just a x in the denominator. So this subtraction is going to actually end up playing into the distributive property, and which is one of the reasons why I encourage you guys to show steps until you become really good at this. So I have to break up the product piece. Here, I've got the log of x to the 5th times y. So that's going to split up using our product rule. But then everything inside is going to become the opposite sign. So I've got the log of x to the 5th. And since it was product, it's going to be addition. And the log of y. Now you could have taken this 5 and put it out in front. I'm going to do that in the next step because I'm also going to take care of this negative and end up distributing it. So the first part, 4 log of z, that doesn't really change. But then I have to distribute the negative. Right? To both pieces, which is going to change the sign of that. So I'm going to first bring the 5 down. And then we're going to keep log of x. So you can see the 5 came down, log of x. But this negative being distributed made this piece negative, and it's going to make this piece negative right here. And that is fully expanded. And I don't know if this is helpful or not, but we went from here to here. We did the quotient rule to write this first step. And then from here to here, we did the product rule. And then basically here, just this 4, that was a power rule. And then again, this 5 here was another power rule. So you can see how we're applying all of these rules at once to expand it out. Okay, so let's try this one. It says use the quotient rule to write the expression as a single logarithm. So what we're doing is we are taking this and it's in expanded form, we want to condense it. So go ahead and condense this. Apply any rules that you need to. And I should say, let's get rid of that because that's a little misleading right now. So the directions are write the expression as a single logarithmic function. Okay, so let's take a look. This is the way I would think of it. We've got two constants, right? Those constants need to go back into the log function and they become exponents. Okay? And then I've got the addition of two logs that have the same base. And that's the thing, that's the key is they have to have the same base. They both have that 10 base that we don't need to write. So if I have addition, addition came from the product. All right. So I would like you to do, actually, you know what? We're going to change this one. Hold on one second. I would like you to do this one, and I'll tell you, this is kind of how delta math is going to work. This is how your answer is going to look. I want you to private message me your answer. What is the value that we're taking the log of? The base b is going to stay the same, but what is this blue highlighted area going to be? Private message me this, and that's my way to check your level of engagement today. I'm going to mark these down. Let's take a look at this. Now we have to really kind of think of what's going on here. So right now I see the quotient side. Okay, so I see subtraction, which means I need to write this as a quotient. And that's the first part. So we've got the log of base b. Now keep in mind this base is always b, so it's the same for both pieces. And then I'm going to rewrite this as 8 over 2. That's the piece that's going inside of the function. Notice there are no exponents because there are no constants. If I had a number here, that would go in the exponent. If I had a number right here, that would go in the exponent. But there isn't an exponent, which means I just have the log of 8 over 2. Well, 8 over 2 can just be reduced down to 4. 8 divided by 2 is 4. So this is the condensed answer. And we do want to take a look at if we are able to reduce 8 divided by 2, then we can do that. Sometimes it's just variables, so we can't. All right, so we're going to do a couple more here. Um, I want you to try these two pieces here quick. Correct. If you can't reduce it, then you just leave it as a fraction. Yep. And you don't have to send this one. You don't have to send your answer for these. I just want you to do these in your notes. We'll go over them in a second. I am going to send a message to everybody that didn't respond, though. All right, let's go over these quick. I was just reaching out to those of you that did not respond to the original request on the last page and trying to get some answers as to why you might not be engaged. Okay, so here's what we got. When I see subtraction, notice there are no constants out in front that would come up as exponents. So this is just 7 divided by 10. And since 7 divided by 10 does not reduce, we're done. That's as far as you can go. Okay. Now on this one, we have a lot of constants out in front. So we kind of really amp up what's going on here. Right away, the 5 is going to come up by the 2. The 7 is going to come up for the x. And the 4 is going to come up here for the y. And then I'll do this just because you can kind of see the steps work out. Okay, so the 5 came up, the 7 came up, the 4 came up. I should note how all of these are log base 4. The only way that all of this is going to be combined together is because we have the same base. So now I'm going to deal with the product, which is the addition piece, and then the subtraction piece kind of at the same time. All right, so I'm going to take the log of base 4, and then I've got a product up top, 2 to the 5th and x to the 7th. Those are being multiplied together, so it was split up through addition. And then it's being divided by the y to the 4th. Okay. Now, the only other thing that they could do here is 2 to the 5th. Well, 2 times 2 is 4, times 2 is 8, 16, 32. So we could rewrite this as 2 to the 5th is really 32. And this is the way that it would be written in delta math, is if you can expand, or if you can, this one you can't, but if you can reduce, they're going to do that. Okay, I'll go back up. I got two more I'd like you to try. You don't have to respond in the chat to these two. I just want you to try them. All right, let's go over these here quick. So, first thing I notice is they do have the same base. They've got the base 10, which we don't need to write, but I have one constant that is going to come out in front. So that's going to be x squared. And then I've got log of 11. Well, the subtraction then is the quotient, and that's going to turn that into division. So we're going to take the log of the same base, and we're going to have x squared divided by 11. And it always goes numerator, denominator, anytime you have subtraction. And since we can't reduce anything, that's as far as we can go. You could put a 10 right here for the base. Now this is a very interesting one because we have a 2 out in front, and this whole thing kind of looks confusing. So this is where I definitely would do 2 steps. Okay? Or actually maybe more, but I'm going to deal with the parentheses first. Okay, so let's take this, and if I have the base 3, I've got log 20 minus log 4. That is going to be 20 over 4, which those are numbers, right? We can do 20 divided by 4. That's 5. Okay, and then officially, this 0.5 is going to move up into the exponent. So that's a constant. It's going to go up. Now you could have brought this 2 up earlier, but notice this 2 is going to go right up here. But wait a minute, isn't 20 divided by 4 actually 5? So I could put the 2, instead of out in front here, I can put it right up top. And now I've got 2 pieces being multiplied together. They have the same base, and addition tells me I'm going to take 5 squared times 4 to the 0.5 power. So we did the addition is multiplication. And then what's in the parentheses here is just simplifying. 5 squared is 25. And the 0.5, this is a little side work. 0.5 is the same as 1/2, but isn't 1/2 the same as the square root? So all of this 4 to the 0.5 power is really just 2. And then 5 times 2 gives me 50. Okay, let's go over these. I'm not sure if that was 5 minutes or not. I think I may have cut it short. But the idea here is when they're a little bit less complicated, could you do them in one step? And that's kind of the goal. So with this first one, I know that the 2 is going to come up here, but I also know that the addition came from a product. So we're basically following these rules, and I'm going to do the product, well, kind of first. This is 4 times 3, but the 2 has to go up here for the 3. So then we've got, well, 3 squared is 9, and 9 times 4 is 36. So I know I was showing you a ton of all the steps, but now I'm kind of encouraging you, once you get the hang of it, you don't have to show every single step. Okay? This one is almost the same thing. The y is a multiplier out in front, so that's going to become the exponent of the k. But then I've got the subtraction, and subtraction isn't the product, it's the quotient. So we're going to end up dividing that one. And they are the same base, so all this works out. So c is going to be on top, k is going to be on bottom, but then the y belongs in the exponent of the k. All right. And then same thing with this one. We've got the r and the 2. Both of those are multipliers. They're multiplying the log, so they're going to go back into the exponents. And then I've got the subtraction, which ends up telling me that's the quotient. And quotient means division. So I'm going to take the log of a divided by d. But then remember, the r is the exponent of the a, and the 2 is for the d, and that's as far as we can go. All right, last one. Notice they both have base b. So we're going to keep the b the same. And then what do I have? I've got 8 minus 4. Well, that minus is the quotient. So it's going to be 8 divided by 4, which we can simplify into 2. Let's see. Definitely write this one down. We're going to do this one together. This one has a cube root in it, and we haven't done anything with roots yet. So this is a quick review. The directions are to expand the logarithm wholly using the property of logs. So we're still working through this. A little bit of a side note. We're going to need this property from before, but remember, if I have our property from before, the nth root of a to the m, that can be written as a to the m over n. This was our exponent, or our radical form into our rational form. And you have to know that to do well here. For example, if I have the third root of x, this is technically x to the first, and then the third root is the divide by 3. So that's what the bottom is going to kind of work out to be. And I don't know if you want to, some people like to write this, some people don't. All I'm doing is changing the bottom so it's a third root, x to the 1/3 power instead of the third root. Okay, so now I'm going to take, and this is the way I like to think of it, I have the division. The division is like the subtraction of the numerator and the denominator. We're going to take the log of the numerator minus the log of the denominator. But then I have the product right here. Right? Z times y squared. Let me make that look more like a z. Z times y squared. This has to be broken up as the log of z plus the log of y squared. And then the last part is dealing with the exponents. Those exponents need to come in front as multipliers. So don't get scared by radicals. We have to use our properties that we learned the other day and turn those radicals, the square roots, the cube roots, turn them into fractional exponents, and then the same properties apply. All right, we're almost done. Last slide here. And why don't you go ahead and expand these fully, these 3 problems. Go ahead and work through them. I'm going to start going over this. You may not have finished, but I want to just make sure we have enough time to end class here. So I'm going to just write my answers. You guys can check them as you go, and I'll explain my thinking as I do it if you want to follow along. But I'm also going to try to do this without showing a lot of steps and see if we can kind of write it all in one step. So I've got the log of 5 times x to the fourth. Well, the 5 times x to the fourth is the product rule. So I'm going to split this up as the log of 5 plus the log of x to the fourth. But instead of putting a 4 here, I know that that 4 is going to move down in front as a multiplier. And then that's as far as we can expand it. Okay. Now the next one, I've got the log of x divided by this whole piece. So I'm going to deal with the quotient first. So it's the log of x minus, now here's the part where we have to be careful. We're subtracting the entire denominator, but that denominator is actually the product, so that's going to be turned into addition. So I've got the log of z. Now it's z to the fifth. There's going to be a 5 up in the exponent, so I'm just going to put the 5 out in front. And then it's going to be plus the log of y to the third, but instead of writing the 3 there, I'm going to put the 3 out in front. Now the only thing I did, or I didn't do, was I didn't distribute this negative, and I wanted to do that as a separate step because do note that this whole piece is being subtracted because it's all in the denominator. So then my final answer would be distributing a negative to each item. So that's my final answer right there. And you know that you're going to have to distribute because you've got more than just one piece in the denominator. If I look at the second one, now I'm just subtracting z squared, which is, I don't have to worry about the distributive property. So I'm going to kind of do 2 steps in one. I'm going to deal with y times x to the third, and that y times x to the third is addition, right? Because that's the product up top. But instead of x to the third, 3 is going to go out in front. And then the divide is just going to be subtracting at the end the log of z squared. But instead of putting the squared, the 2 is going to go out in front. So it's a little easier when you just have like one variable in the denominator versus 2. Now, if you don't like skipping steps, don't. Show your work, show the steps, and you'll be good. But I also want to show you that you are able to do these kind of more in your head once you become really good at it. Okay, so what I'm going to do right now is we have 5 minutes left. Your homework tonight, uh-oh, my computer just froze up. I can't switch to the next screen yet. Your homework tonight is section 3.4 in Delta Math. And I talked about this at the beginning of the hour. Some of you weren't here for the first day of class and you missed how to join the new Delta Math class. So you either need to stop into my office hours from 1 to 2 today or watch the video from class on that day.